Hey, we're going to talk about dividing scientific notation, or the how many times larger problems. A couple things to go over first of all. First, in scientific notation, we need to make sure that the first number is between 1 and 10. All right, we call this the coefficient. All right, so the coefficient, say 2.3, that number has to be between 1 and 10. And then the power of 10 has to have an integer exponent. All right, so it can be positive, it could be negative, but it has to be an integer exponent because basically what we're doing is our number system, we call it the decimal number system, the prefix DEC actually means 10. We use a base 10 number system. So every time we have a power of 10, we're moving a place value. If you think of, we have the ones place, then the tens place, then the hundreds place, thousands place, and so on. Those are all powers of 10. So that exponent is telling us, okay, we got to move 12 places. That's where that comes from. So we need a power of 10 with an integer exponent. Integer exponents, if it's a positive integer, it means that the number is greater than 1. So those are the really big numbers, like millions, billions, trillions, and so on and so forth. If the exponent is negative, that means the number is less than 1. So they're super small decimals, 0.00002, 0.000000005, things like that. All right, so those are the basics. And like I said, a main part of this, especially when we're dividing and multiplying scientific notation, is making sure that this coefficient is between 1 and 10. If it was, say, 23 times 10 to the 11th, that's not okay. That's not scientific notation, so we need to make that into 2.3. So basically what we would do, and we'll look at this a little bit more in depth, but this is a really big number, all right, 23.00, so on and so forth. So basically the decimal moved 11 places to get it to after this 23. We got to go one more spot, which would make it 2.3 times 10 to the 12. All right, so those are the basics about scientific notation that we need to know. Hopefully you're pretty familiar with those. A couple other things we got to talk about are exponent properties. So when we have exponent properties with the same base, now obviously we're going to be dealing with tens, all right, but this is called the product of powers. This is a power, and we're multiplying them. We add the exponents in that situation. For example, I'm going to use powers of 10 here. Say I had 10 to the third power and 10 to the fourth power. Altogether, we take 3 plus 4 and we get 7. Reason being, this is literally 10 times 10 times 10. So 10 3 times. And we have times 10 4 more times. Altogether, we have 7 of them. And since it's repeated multiplication, the easier way to write it is in exponential form. So one idea of exponents is when we multiply powers like this, we add the exponents. If we divide, which is what we're going to be looking at with dividing scientific notation, we subtract them. So if I have, say, 10 to the 5th over 10 to the 3rd, we subtract those and we get 10 to the 2nd. Reason being, this is 10 times 10 times 10 times 10 times 10. And we have 3 tens. Anytime you have a common factor in the numerator and the denominator, they cancel each other out. So we're essentially saying we have 5 tens and we're taking away 3 of them. So we're left with 2. So now let's look at the how many times larger problems. So if I have mountain A, and I'm just gonna make things up. We're gonna use easy numbers here. Let's say mountain A is 3,400,000 feet tall, and mountain B is 1,700,000 feet tall. So how many times larger is mountain A compared to mountain B? That's a division problem. So we have to divide 3.4 million by 1.7 million. And to do that, it might be easier to change these into scientific notation. So remember, we want to move the decimal so the coefficient is between 1 and 10. The decimal is right now at the end of the problem. We want to move it between the 3 and 4. All right, not after the 4. We don't want 34 because 34 is not between 1 and 10. We want 3.4. So we're going to have 3.4. And then we want to talk about, well, how far did this decimal move? It went 1, 2, 3, 4, 5, 6 places. This is a large number, bigger than 1. So we're going to say 3.4 times 10 to the 6. All right. Next one, all right, we're going to move it over. Once again, it's going to be 6 spots. 1, 2, 3, 4, 5, 6. So it's 1.7 times 10 to the 6th power. All right. So if I had to divide these, I'm looking at 3.4 times 10 to the 6 over 1.7 times 10 to the 6. So when dividing in scientific notation, we're going to look at dividing the coefficients first. So I'm going to take 3.4 divided by 1.7, and I get 2. So my coefficient is going to be 2. And then remember that property. If I have the exponents and I'm dividing by them, I'm going to subtract these exponents. So I'm looking at 6 minus 6, which is 0. So I get 2 times 10 to the 0 power, which brings me to another property. Anything to the 0 power is actually 1. So this is 2 times 1, or just 2. So mountain A is 2 times larger. So that's just, like I said, I wanted to start with a real simple problem and show kind of the basics. Now let's go to a little bit more advanced problem. So let's look at mountain A. Let's make mountain A pretty big here. So we'll go 4.5 million feet. Mountain B isn't going to be nearly as high. All right, so let's say mountain B is just 12,000 feet tall, which is actually about 2 miles high. That's actually pretty large. Mountain A, I don't think something exists like that on Earth. All right, maybe in inches. So once again, I'm going scientific notation. I'm going 1, 2, 3, 4, 5, 6. So I got 4.5 times 10 to the 6th power. Now here, I'm going 1, 2, 3. I'm only going 4 spots. So this is 1.2 times 10 to the 4th. All right, so getting them in scientific notation early makes it easier to have an answer in scientific notation at the end. So how many times larger is A compared to B? I'm going to do 4.5 times 10 to the 6 over 1.2 times 10 to the 4th. All right, and division, fractions really mean division. So that's why I'm writing it as a fraction. Also, I think it's easier to deal with fractions and go horizontally with a division sign because it's easier to look at, okay, I want to line up my coefficients. So I'm going to take 4.5 divided by 1.2. So that gives me 3.75. And right now we're good because this is between 1 and 10. All right, we're going to do another example later on where it's not between 1 and 10. And then the exponents, remember, I'm going to subtract these. So 6 minus 4 is 2. So my answer would be this is 3.75 times 10 to the 2nd times larger. All right, so getting them in scientific notation might be a little bit easier. Now, what if we didn't want to do this in scientific notation? What if we wanted to just take, I'm going to leave that answer up there for a second. What if we just wanted to take 4,500,000 divided by 12,000? That's perfectly okay. All right, if you did it that way, that's fine. Try to get the correct number of zeros in here. So I get 375 as my answer. Well, what if I have to change that back into scientific notation? Look at what our other answer was in scientific notation. The decimal was here. We have to move it 2 spots to get 3.75 being in between 1 and 10. So we can have it work that way as well. All right, let's go one more problem. A little bit more advanced here. So now that I realize that 4.5 million feet is way too big, let's change it to inches here. We'll make it a lot of inches. 57 billion inches. All right, and then let's make mountain B, we'll say 72,000 inches. All right, so we could go ahead and divide these numbers if you want, but I really think it's easier to do this in scientific notation from the very beginning. So I'm going to look, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 10 times, so I got 5.7 times 10 to the 10th. This one I'm moving 1, 2, 3, 4 times, so 7.2 times 10 to the 4th. Okay, now I'm going to divide these again. So I got 5.7 over 7.2, and I got 10 to the 10th over 10 to the 4th. So this is going to present a little bit of an issue. And I'm going to round this. I don't know if you can see my calculator on there. Try getting a little bit light. It goes on. So I'm going to round it to a number to use. I'm going to go to the nearest hundredth. So we'll say 0.79. Well, that's good. To the 7th. Yeah, so 0.79. So 0.79 there. And then once again, I'm subtracting my exponents. 10 minus 4 is 6. Now, hopefully you're looking at this and say, we've got a problem. All right? This is not between 1 and 10. That gives a little frowny face. That's not a good thing. That's not scientific notation. So we got to figure out how to change that into scientific notation. And there's two ways to do this. I'm going to go ahead and erase those real quick. So I want to take 0.79 times 10 to the 6th power and change this into scientific notation. So one way to do it is change this into scientific notation. I know this number is smaller than 1. Oh, I might have had some technical difficulties there. I wonder how much we lost. So I know that this is smaller than 1, so I'm going to need a negative exponent, but I only got to move it one spot. So it'll be 7.9 times 10 to the negative 1st times 10 to the 6th power. So what this is telling me is, if you remember that one property, when we multiply, we're actually going to add the exponents. So I can take negative 1 plus 6 and get 5. So 7.9 times 10 to the 5th power. Another way I can think about it is this number was a really big number. All right, 10 to the 6th power. So the decimal was there. So my number was coming from this direction. Actually, 1, 2, 3, 4, 5. Would have been right there. My decimal was coming from this direction 6 spots to get here. But that was one spot too many. All right, so I can say, well, I went 6 spots, but I really wanted to cut it down one more. So that's how I can figure out that it's times 10 to the 5th power instead of 6, because that number was not between 1 and 10. Either way, this is going to be our final answer, 7.9 times 10 to the 5th times as large. You could have done, and I'm blanking on what my numbers were at this point, 5, I think it was 57 billion or 5,700,000,000. You could have divided that by 7,900 and you would have gotten this number. All right, you would have gotten 790,000, and then to change that into scientific notation, once again, the decimal is here. We need to move it there, so that goes 1, 2, 3, 4, 5 spots. So it'd be 7.9 times 10 to the 5th. All right, that's also a way that you could have approached this problem. All right, but that's how we divide with scientific notation. I also went over a little bit how to multiply in scientific notation. While I'm here, let's just do a quick example. So if you ever had to multiply scientific notation, say 1.2 times 10 to the 5th, and then we're going to multiply that by 9.8 times 10 to the 7th. All right, I multiply the coefficients just like before where I divided. So 1.2 times 9.8, that gives me 11.76. And that's an uh-oh, because that's not between 1 and 10. But then I got times 10 to the 5th and times 10 to the 7th. We're going to add those together. So I got 11.76 times 10 to the 12th power. And now we just got to address this. Why isn't this between 1 and 10? Or how do we get this between 1 and 10? So, like we did before, sometimes I change this into scientific notation. I got to move that decimal over one spot. So that's 1.176 times 10 to the first power. And then I still have this times 10 to the 12th. And I add those. So it'd be 1.176 times 10 to the 13th power. So if we ever had to do a multiplication problem with scientific notation, that's a quick rundown of how it would work. It's very similar to the division. Obviously just multiplying the coefficients first, adding the exponents, and then adjusting if that coefficient is not between 1 and 10. So hopefully this video helps you a little bit. As always, any questions, send me an email, and I will do my best to help out.